And finally, our final round. Now, when we read this, it's going to seem difficult. It's going to seem that way. The purpose of this round is to see how you can recycle answers. We've solved things already. We've solved them generally already. And so how can we reuse those problems that we've already seen and solved for? If you'd use numbers for everything, you couldn't do this. But since we have solved everything in a general sense, we can do it. All right. We're going to walk through this a little bit by bit. First things first, right? You could draw your picture if you want. Second thing second. Which one of these is going to be the correct velocity graph? The red, the green, the blue, or the orange? Give it a pause, give it a try. In this case, well, we actually have already seen it in regards to the data, right? So let's look at the data that we saw. Data looks like, was it the red one? Is that what it is? Something that starts positive, goes to 0, increases in the negative. That looks like our winner. So that is red. So the red one is the correct answer there. All right, so that's what your velocity graph should look like. How about your acceleration graph? Give that one a try. Hopefully here we're ending up with free fall, right? Don't fall for the brown one, right? Don't fall for the brown one. It's the green one, right? Always negative, always constant. Okay, so that takes care of our graphs. Now let's look at hint 1 and hint 2. Remember, hint 1 is what I talked about at the beginning. Recycling answers, totally allowed. What have we done so far? Well, we've solved how far up an object goes when it's thrown up, right? And then we have solved for how fast something is going when it is dropped. Right? Those are the two things we've solved for. Thinking about that and then saying, okay, I can choose any 2 points to analyze this situation, right? I can analyze using the beginning and the end, or anywhere in between, any 2 points. I have to choose one of them as this guy right there, our Y2, right, location. Now, sorry for if this is confusing, right? It has a height of Y1. I guess I necessarily don't need to say that Y1. It's some height, right? You could just say that's H if you wanted to, because we've been saying Y1 is the location in the analysis, right? So where would you put that initial location when we're doing our analysis? That's where the blue comes into play, right? Is it going to be the top, where it's at the max height? Is it going to be the ground, where it's down here? Or is it going to be the height of the volcano? Give it a try. Hopefully, well, you trust me on this one. We're going to choose the top to be our Y1. Again, the purpose for this is to show recycling, right? Because when we use Y1 as our analysis, what's my velocity up here? It's equal to 0, right? Okay, so I just end up with something that's dropped from 0. We solved that problem, right? Go look at it. And when you look at it, there's going to be one tiny problem, right? The one tiny problem is we need to know what that max height is, right? But we've solved for that too, right? We've solved for that already given an initial velocity. How high does it go? We did that in the last round. So you can take those two solutions and you can piece them together to get to a final solution, right? Right? The answers are from up above. You should have them in your papers, right? Go look at that. What's your velocity? What's your height? Put them in there and you should be able to come up with a general equation on this, right? Now, I don't say it'd be irresponsible for me to not say this, but I will note, right? All of these problems we've done so far have not involved time. There is one very nifty, handy equation called V2 squared is equal to V1 squared plus 2a y2 minus y1. Very nifty. You could solve this problem with that, wash your hands of it, and be done, right? But you don't learn as much physics that way. You don't practice as much physics that way. You don't practice as much problem solving that way. So if you want to use that equation, you're certainly welcome to when you're trying to solve these problems when you don't have time. It's a good go-to, right? Most of the problems that we assign to you, or at least that are going to be in your quizzes and probably on your exams, are going to be very similar in terms of the substitutions you'd be using in this particular activity. But you have that guy right there, v2 squared equals v1 squared plus 2a times the displacement y2 minus y1, right? So I just want to make sure that was there. Use either one. Either way, you have one more little piece to do today, which is solve the problem with numbers. Again, it gives you a nice full page here where you can go back and you can try to solve this all on your own. If you can do this one all on your own without having all the previous knowledge either, without, of course, just jumping to the v2 squared equals v1 squared plus 2a y2 minus y1, but if you can go through that whole process, you should feel pretty good about your ability to do physics. So once again, do that problem, and then we're all done for this 1D kinematics in free fall.